In today's rapidly evolving industrial landscape, companies face the critical challenge of enhancing their automation processes. Traditional condition monitoring, while effective, offers a narrow perspective on machinery health. Advanced Industrial Internet of Things, or IIoT, technologies present a transformative solution. By integrating sensors and data points across entire systems, IIoT provides real-time, comprehensive insights. This approach not only predicts maintenance needs with greater accuracy but also minimizes downtime and boosts overall efficiency. The key to unlocking these benefits lies in the seamless integration of programmable logic controllers, or PLCs, with IIoT solutions. This integration creates a dynamic ecosystem where data drives decision-making, leading to smarter, more responsive industrial operations. As we delve deeper, you'll understand the exact mechanisms and strategies that make this possible, setting the stage for a new era in industrial automation. Now, let's delve into the core principles of IIoT in industrial automation. At its heart, IIoT transforms traditional condition monitoring by offering a holistic view of system health. Unlike conventional methods that focus on isolated wear points, IIoT integrates sensors and data points across the entire system. Imagine a network of sensors communicating in real time, providing continuous insights into machinery performance. This approach allows for predictive maintenance, reducing downtime and enhancing efficiency. The key here is the seamless integration of programmable logic controllers, or PLCs, with IIoT technologies. PLCs control machinery and processes, and when paired with IIoT, they elevate monitoring and control capabilities. For instance, using development environments like the TIA portal, engineers can program PLCs to interact with sensors, creating a unified information flow that optimizes both monitoring and operational efficiency. This interconnected strategy is fundamental to Industry 4.0, where data exchange and automation technologies drive manufacturing excellence. And here's why that matters. To begin setting up your IIoT solutions, you'll need to start with the PLC configuration. First, ensure your PLC firmware is up to date. This is crucial because outdated firmware can lead to compatibility issues with your IIoT devices. Next, configure the communication parameters. Set the baud rate to 19,200 for most legacy devices, and ensure the data bits are set to 8, with one stop bit and no parity. For network settings, choose UDP over TCP if speed is a priority, as this will reduce latency. Remember, every millisecond counts in a real-time environment. Also, enable the Keep Alive setting to True to maintain consistent communication. This will prevent unexpected disconnections. Now, let's talk about sensor integration. Connect your sensors to the PLC using the appropriate analog or digital inputs. For analog sensors, use the AI blocks in your PLC program, and for digital, use the DI blocks. Make sure to calibrate your sensors according to the manufacturer's specifications to ensure accurate data collection. This is where the magic happens. Your PLC will start collecting real-time data from your sensors, giving you unprecedented insights into your industrial systems. Now, let's dive into the execution and code logic essential for IIoT integration. The first step is configuring your PLC to communicate with the IIoT platform. Begin by setting up the communication parameters. Use a baud rate of 19,200 for reliable data transmission. Next, define the data points you want to monitor. For instance, specify temperature, pressure, and vibration data. In your PLC program, create a loop that continuously reads these data points and sends them to the IIoT platform. Use a timeout parameter of 500 milliseconds to ensure timely data transmission. If you encounter error code 8001, check your cable connections and update the driver. For optimal performance, choose UDP over TCP for data transmission, as speed is critical in this application. Remember, the goal is to create a seamless flow of data that enhances both monitoring and operational efficiency. And here's why that matters. When you dive into advanced IIoT solutions, you'll encounter edge cases that require specific optimization strategies. For instance, consider the latency issue in data transmission. To minimize this, Set the sampling rate of your sensors to 100 milliseconds instead of the default 200 milliseconds. This reduces data overload and enhances real-time responsiveness. Another critical parameter is the PLC scan cycle. Aim for a scan time of less than 50 milliseconds to ensure swift data processing. Additionally, when integrating multiple sensors, use a consistent naming convention for data points to avoid confusion. For example, prefix all temperature sensors with temp underscore. This practice not only streamlines data management but also simplifies troubleshooting. Remember, the key to optimization lies in meticulous parameter tuning and consistent data handling practices. Navigating the landscape of industrial automation, you'll encounter several common pitfalls. One frequent issue is data inconsistency across sensors. To resolve this, ensure all sensors are calibrated to the same standards. Another challenge is latency in data transmission. This can be mitigated by optimizing your network configuration and using protocols like MQTT for efficient data handling. Additionally, PLC programming errors are a significant hurdle. Always double-check your logic and use simulation tools before deployment. For debugging, start by isolating the problem. Use logging extensively to trace data flow and identify anomalies. Remember, the key to effective debugging is a systematic approach. Break down the problem, test each component individually, and gradually reintegrate them. This meticulous process will save you countless hours and prevent production delays.